That's when the student worked.
Emma's coming too.
She just text in the group chat and stuff. She's in
Huh? I have been running around all day. I've got like these, it's really bad. I'm like, lately I've got so many, the thing I went into this profession for is not the thing I'm doing anymore. It's just till I do math. I'm just too busy like advising people and going to meeting administrative stuff. It's really depressing. I love doing math. That's why I did this. But I don't find time anymore.
We're right there.
It's a question of like score. I do that and I'm right in front. I think I might just plug in over here. That's a bad idea. So
Math.
Math, right? That's kind of. Oh, guys, I'm loopy. I don't know what's going on. That's the other thing, you know, having children is really when I work. Children. Don't do it unless you're ready. Okay. It's rewarding. Okay. On, of course not. Okay. Go. Ish. So. That's okay. Sorry.
If you want to, you can.
Hey, this is a relaxed environment.
You have what? I'll just shoot it. I'm shooting on Saturday anyway. I got you. Like,
good.
Shooting baseball on Friday and Saturday now.
Shooting?
I'm a photographer.
Oh, that's right.
That's why she's leaving her house.
Is she coming here or is she?
Yeah.
All right. What's up, guys? Let's do a couple of problems before I have to close this down. What's up?
First problem is number 4. So.
Okay, what do you think of that?
A is just take it. It's just adding the 2 numbers together and dividing by 2. You get 5/5.
Yeah. Okay. Good. So give this kind of picture, which I'm going to very poorly sketch, and I guess they're giving us our standard deviation is 400. Is that the right figure?
Yep.
And 450 centimeters.
And 560.
And so, yeah, as you point out, right, this is, if you want the median, this is going to be the average of these two. So, what's that, 550? I can't. 560 plus 450. Okay, so that's 1,010, so 505. Right. So A is asking what the median is. And yeah, as you point out, it's the average. So median equals, I'll just write it out.
And you have to do, and then from B, for like the standard deviation, you have to use that formula.
No, I mean, well, no. So for B, standard deviation. So here you just want to look. I mean, I will look. You generally want to look. You want to find this inflection point here, which should be. It's going to be your P or your P prime or your inflection points. Right. And your standard deviation is the distance to the mean.
So it's just, it'd be 450 to 505.
Which is?
55.
55. Or 560 to 560. You getting it?
Yeah.
It's okay. Now this is where you're going to use this equation.
Is it so for the standard deviation? Is it always the one to the left, or could it be the? I guess no, because it's half. It's half.
It's not. It's you're answering your own question.
55 for either one.
Right. It's the distance, you know, to either inflection point. Right. So from the median. X distance. I mean.
And this is the one where you.
So here you do this kind of 0.6575. Because I always forget these numbers. I know 0.6. 0.6. I spend my time remembering. Bad for your health. 0.67. But I remember them, even if I don't want to. So, yeah, your third quartile is going to be your median or your mean, either one, plus 0.675 times your standard deviation. That's a general formula. Am I doing first or third? I think I'm doing third. Okay. So, yeah. So this you just have to put into a calculator because I don't have off the top of my head 0.75 times 55 what that is. Someone can tell me. What is it? Excuse.
$87.125.
Okay, and then this should be, so then 592. And right here, honestly, this is, I'm gonna be honest, that's an approximation. It's not, it's really, one of the reasons I don't memorize this stuff is because these are all really approximations. So when I find it, there's an actual number probably involving pi and e and stuff. Okay. First quartile is the same idea, but we subtract. So Q1, approximately, median, mean, whatever, minus, sorry. Okay. already calculated this, is the product. 505 minus A7. 5, which equal 4. I'm unable to add all this, so 4, 18, 17, 4, 17.
You want it?
Huh? Yeah, go ahead.
437.875.
437. That doesn't sound
Yes.
right.
417. 417.
I would think it's
505 minus 87.125. Oh, sorry. Yeah, I have it.
Is
417.
that
Yes.
good? So I do want it. Okay, that's enough. It's okay, guys. All right, that was not very fun, but okay. I mean,
At least you know the truth.
the truth is, yeah, no, look, I'm not a big fan of just putting in numbers into formulas. I am a big fan of understanding what these things mean. Like, I think that's kind of helpful. And I really I'm not doing a good job explaining this stuff. I know that, so I'm trying to think about how I can do it. It's hard.
Did you say it was the first time teaching this class?
It is my first time teaching this class, and hopefully the last. I think other people do a much better job. I just don't know how to approach this class.
They just tell you to teach the class.
Like,
You have to say.
hey, you're doing this.
Huh?
Was it kind of like a hey, you're doing this type of thing?
Well, normally I sign up to teach graduate algebra. So usually I take every 3 years, I'll take a year off from teaching the grad courses because I want to give other faculty time to do it. And so I did that. I didn't put a request in, and they gave me this because they needed something to do it. So I think I needed to set this up more. I needed to not take what I needed to make this my own class. And I'm teaching things that other people are happy to teach them.
Right. So. Glad you're here, though.
Huh?
We're glad you're here.
I'm glad you guys are.
I graduated.
You could be rude.
So I'm happy.
Huh?
You could be rude.
Rude? I try not to be rude. We just did one problem.
Okay, take a picture.
It'll all be online too. So anyway, what's up? What's next?
I'm just having that. And then one of my friends screamed at me from my car,
She's dying.
and I'm nice and didn't want to just ignore them. So then I, of course, went and gave them a hug and then sprinted here. So,
You park where you
Friends
park
are the
this
worst.
morning.
No.
Does that symbol on 8A like
Simple. What is that?
the,
On 8A?
does
Mu?
that have a purpose?
Mu?
That's what
I
it
don't know
looks
what that
like.
is.
I've been using that like over and over again in lecture.
Yeah.
You guys have to ask questions though. I
No,
swear.
you're
I'd be nice.
an M. That's what
I'll
it looks
be-
like.
that's
This
what
is mu.
it is.
That's mu.
No.
Greek letter
No.
mu.
Wait,
Which is M in Greek.
is that it?
That's not what I've been.
This is capital.
It's like a
That's capital M.
I've
that's
been
capital
just
mu.
making it like.
it's like an upside down H.
Wait, what?
Hold up.
Mu.
Okay, I've just been
It's a
making an
Pokemon.
M, but I've been going like this.
It's Greek for M, so you're close.
Okay, what?
Okay,
That's mu.
we're on 8.
Mu.
And it's
Find
5:30.
the mean mu of the distribution.
Mu is generally the mean
What?
for any kind of distribution. That's
Hey,
the
it's
symbol for the
5:30.
mean.
Oh.
Yeah.
What time?
I've been using it in lecture. No one says it.
Do you have to say? Do you treat it like the same? Like do you just?
It's just the
My show is
mean.
really early in the morning. So.
Yeah, usually like.
I'm not usually awake. Like this
People are on
morning,
their phone.
I was dead this morning.
Well,
I was.
So just 229 plus.
Okay, so hold on. So this is 8. 8A. Hold on. 8. Consider a normal distribution with first quartile Q1 equal to 229. third quartile is Q3. Now the first question is find mu. Find the mean. Now this is not a hard problem because Q1, as we've seen, I'm going to write equal here even though it's approximate, is mu plus 0.675 times sigma. Q3 is mu, sorry, this is minus, plus 0.675 sigma. If I add these two, I get Q1 plus Q3, right? I get mu plus mu, that's 2 times mu, right? And then I get plus this, which is negative. So something minus itself. That cancels. Right? Yeah. So what that tells us, if I divide this equation by 2, I get mu is equal to Q1 plus 3 over 2. And then we can use that. To find mu, we have these two quartiles. So putting the numbers in, we get mu equals 229 plus 391 over 2, which is equal to 620. Sound good? On John Surf Shop. That's from Miami or no? There's one in Miami, I know.
Oh, this one's from the States.
I guess it's like a chain.
You got one in Panama City
I was
Beach.
like, what?
Just a
What are you
reminder.
looking at?
And I forgot that it was there.
When do you know when to like add and when to subtract one?
Sorry?
Does it matter which does it matter
For this part, for A or B?
Q1, for A, like the first equation, does it matter like which one you add and which one you subtract?
Yeah.
You're gonna get the same thing, but
No. What do you mean? The first quartile, you need to use subtraction. Third quartile, you need to, but when you add them up, they're going to cancel. And so this equation, there's no, it's just that all this equation is telling us is that the mean is the average of the first and third quartiles. Right. But I'm just trying to show why that is. But now for B, you do want to kind of, your question's I think more relevant for B, which is to find the standard deviation. No, guys. What's wrong?
Nothing.
She was just because I didn't remember.
You
That's
guys-
a shit.
Huh? You swore? You
I
cursed?
almost did.
She
I almost.
You curse. I remember the last time I
It's okay, you're all adults. You're allowed to curse. I
That's
think.
my mother.
Well, I'm not gonna get involved there. You're allowed. It's legal. It's not like not necessarily wise, but it's legal. Okay, so here, no, we don't have to do any variance. We just have to look again. I mean, we have these wonderful equations that we love so much. We found mu. We can throw that guy in. We have Q, well, Q1, I guess. We can throw that guy in. And then we're just left with sigma. We can figure it out. So let's do that. Let's actually, let's do the plus. Let's do the third quartile. 391 is equal to 310 plus 6.675 times sigma. 3/8, or wait, 5/8. Is that 5/8, 675? No, that would be 625. I don't know, something. Anyway, you guys can tell me. So subtracting both sides, we'll get 81. It's equal 0.675. And then you guys have to help me out with the calculator. What is that? What's the fraction? Hanukkah is 27. Times 3 is 81. Because it's 20, right? $27.40. So you divide that, you're getting, yeah. Yep, okay, that makes sense. So this is like all right. So what's the next problem? Or what's the next problem if anyone wants to like do something? We don't have to do problem by problem. Go through them all. We can go through a few others. 12. The next one is 12. Explain why a distribution with median in 453 mean 453 first quartile Q1 343 third quartile Q3 equaling something 553 cannot be normal distribution. I don't think so.
Wouldn't the median have to be lower?
Why don't you tell me?
If you add Q1, and Q3 up and divide by 2 is 398.
Okay.
And on there it says 453 for the median, and then mu.
Right. 453. How do people feel? Do you agree? This is expert analysis. Huh? It makes sense. Okay, well, there's by an overwhelming majority of 2 votes, 1 abstention. There is a consensus. Where's Christian? Where's our guy?
He's at home.
Well, he's
Not
driving,
here.
He's
At
driving
home.
He's driving back from Argonia.
Is that a country?
He says country. Sounds like it.
He's in his own home.
It's in the country.
He really did.
He is now at his apartment 2 hours ago.
All right. That's all right. Okay.
Always.
So I think the answer here is mu is not equal to the average of Q1. And would need to be.
Can we just write that? We have to like write in words.
Well, you can say because.
But because. Okay.
So that I know that's the reason. I mean, they ask what the reason is. Why can't it be? Because this. You know, I don't mind. Hitting my head on the wall. Teaching. All right. Anyway, next question.
Find the data of that.
What is it? So if we're looking at z values in 20,
That's always fun.
but it's giving us the z values.
Oh, they're asking for the data value
Yeah.
corresponding to that. So they're doing the opposite. So okay, so we have normal distribution, normally distributed data set. Got mean 83.2. Standard deviation. 4.6. I'm going to find the data points or data value. This is what we've been using as X. Corresponding to A. Z equaling 5. This is a lot easier than the other. I mean, I don't know if it's a lot easier. Both easy. Am I doing the wrong one? I was supposed to do 22? 20.
You're just writing the wrong numbers.
Okay, do I have the right ones for the first?
Yeah.
Okay, good. Z equaling 0. Thank you. Sorry, my eyes wandered a bit. This is even easier than this. Gosh, I give you guys easy problems. Okay, well. No time to like waste here.
Would be at the middle, which would be mean, would be wow. Woo!
What do you do for this one? Like you just.
So this one was right. So this one's the point is we have this equation. X is equal to Z. Our equation was Z is equal to X minus mu over sigma.
Oh, mu.
Okay, mu. This is well known. And I gave you the other equation, X is equal to mu plus sigma Z. So this is the one that's easier to use for this particular problem. So you're going to plug, they got the mu, you've got the sigma, and you've got the Z. So all three of these are given to you, and then you just calculate if you want. Right.
I don't know if I'd be right, but I got 92.4. Because once you add 4.6 twice to 83.2, or you only add it.
What did you say, 92.4?
Yeah.
Yeah, that's right. So I'll write it out a little bit though. So if X is equal to mu, I'm going to write it all the way up, plus sigma Z, which is equal to 83.2 plus 4.6 times 2. Now that's 9.2. 9.2 plus 83.2 is 92. Yeah, like just really just putting in numbers. This question. Yeah.
Sorry, I'm looking at 32.
And you can do that for like every Z value type problem.
Well, okay, so there's sometimes you're given Z, asked to find the X value, sometimes you're given the data point or X, and you're asked to find the Z value. So depending on what you're given, but it's the basic, I mean, you're using the same equation. It's just a question of what variable you're solving for. Yeah.
A, would you add 40 and 4.2 is 10.2 and divide by half to get median to get that would be like in the middle.
Yep, to find A, yeah, you're just going to take the average. Although, okay, I mean, it's true. You have to kind of judge that this is indeed like symmetric, this region. But I think it's pretty clear. I'm sorry? It's your problem, actually, quite literally.
If the line's in the middle, it looks like it's in the middle.
Okay, there you go. That's good enough for me.
I don't know if it is or not.
So then, is this the part where we need to use variance to get the
No. The variance stuff that I was using today was really intended for the last section to explain to you. I was trying to go a little beyond what the book is doing. In particular, I was trying to explain how the central limit theorem implied the results of the book. So the results of the book, they don't seem to talk a lot about the central limit theorem, but they do talk a little bit about some of the consequences of it. So I was trying to make that link, but of course that was ideas for this course, not good ideas. So it's hard. It's really upsetting because it's probably the nicest theorem we have. It's a very good theorem. So it would be great if I could explain it to you guys in a way that made. But anyway, I won't lament that anymore. It's just, so that's why I was talking. I mean, you need to know variance if you want to understand what standard deviation is. And so, but we're kind of, most of this stuff in this chapter just assumes that it doesn't really go back and calculate.
Then how would we find it?
Okay, so we're talking about 30, which one, 32? 32B? Yeah. Oh, second part of A. Oh, okay, good. Yeah, so the 32A. So the picture was, you have this guy, and they kind of give you the 95% part. You got 4.2 here, 10.2 here. Is that right?
Yes.
Okay. And the mean is the average here. So what is that? 7.2. So I'm going to write it out. And this is ounces, okay, yeah, thank you. Should always kind of keep your units, but I'm a little sloppy sometimes. 7.2 ounces. All right, and now the standard deviation, this does come from sort of, you're supposed to kind of know a fact.
Well, no, on the graph, it's like that halfway point, not halfway, but like on the slope going down. That's what it's saying. Is that like that 60 something, right?
Okay, you got a lot of numbers here you're throwing at me. You got 60s, you got choo-choo trains, you got all sorts of stuff going on. What's happening? What are we doing? What are we talking about?
Have a name.
She's on the right track. Yes, it's in there. You guys got it? So how much, we have this rule, it's called a rule, 65, 66, 95, I think it's 66, I always forget.
I only
the
remember
numbers.
95.
66, 95, 99.7. This is the 68, I screwed it up. 68, 95, 99.7. I don't know this stuff. 68, 90. But the point is, we know that there is a rule. What is that rule talking about? You don't need to remember the numbers, but remember what it's talking about. That's what I want you to remember. It's giving you the probability of landing within 1 standard deviation, 2 standard deviations, or 3 standard deviations. That's what it's doing. That's what the rule is all about. So here we're given 95, which is probability of landing within what? Of the mean. You guys don't listen.
I'm trying to find it in my notes.
Don't worry about your notes. Just let's pay attention. Okay. The rule is we got these numbers 68, 95, 99.7, right?
Yes, yeah.
Okay. What are those numbers? What are they telling us? 68 is telling us the probability of landing within 1 standard deviation of the mean.
Yes.
95 is telling us the probability of landing within 2 what? Standard deviations of the mean. So we are given a picture with 95%. So that's saying that we're landing within 2 times the standard deviation. So we look at the distance of the mean, and divide by 2, and we should get our, not 7.2, that's the mean, the distance from the mean. So we got this picture here.
So
Here's the mean, that's, we calculated was 7.2. And we should have that this distance here is twice the standard deviation, this distance.
oh, okay, so 10.2 minus 7.2 divided by 2.
Is. Oh, no, you don't need a calculator for that, please. Please don't do that.
I
10.2 minus 7.2.
1.5.
It's 3. 1.5. Thank you. Oh my goodness. Please, I'm not judging you. I just am kind of judging.
I wanted it the right.
You're
answer,
concerned.
so-
When I take an exam, I always have to type in like the simplest thing into my calculator to make sure it didn't change. Like
Okay. Sometimes you need calculators. Sometimes they actually slow you down.
B.
B.
First quartile.
Okay.
So then we have to.
Let's do the third first. What do I do? I'm not. Say again?
I was reading it.
Okay, sir.
I just blanked on that again.
Just waiting. Get it figured out. 16.
So I'm gonna look at the picture that you took.
Well, you tell me what's going on. What should I do?
Yeah, you got it.
Would you just use the equation that we did in for C and number 4?
Probably. What is that equation?
Probably.
Tell me what it is. I'm asking you. I'm like not.
I haven't found yet. Hold on.
Oh, you want? Oh, I see. You're asking for the equation. Okay.
No,
Okay.
I'm writing it down.
Okay, tell me.
And then
I'll write it. I'll write it down with you. What is it? What should I write for Q3?
U plus 0.675 times sigma.
Right. That's right.
I don't have the numbers in yet.
That's okay. I'll put this in, and then you guys, you tell me what I should get. I don't really know how to do this. It's awful. It's not that bad actually, but okay.
I can't always be the most ladylike person ever.
Not always, not always. And then me neither.
Look how I'm sitting right now.
Exactly.
I can't sit normally in a chair, and my roommate makes fun of me for it.
Wait, I have to do
11.8125.
0.675. Say what?
11.8125.
The whole thing?
Yep.
Do I believe that? I don't know if I believe that. 11.81.
That's bigger than the.
Yeah, that looks a little too big. Looks a little too big. What happened?
I got 8.2.
Yeah, I think that sounds closer to me. I think you're missing a parentheses or something. 8 point what?
It would have to be 8.2. It says around here.
I believe that then. That looks closer to me. That looks very close to me. You're multiplying, you probably did this. Multiply that. The 11.
Probably.
Multiply this first. Order of operations. Multiplication first. This should be minus, pardon me.
46.2.
I believe it. I don't know. Yeah, I believe it.
Sure.
Huh?
Like, sure.
No. I mean, the point is you can just take 2 times the average and subtract this, and you should get this. 2 times mu. That's 14.4 minus 8.2. Some things aren't hard. Something. Okay, guys.
62 or something.
62?
Yeah.
That's skipping.
I know every time you do it, I always get stuck on the problem.
One more time. Not much. 62?
Let's do 62, and then if you have questions, I'll bring them in on Wednesday.
Yeah, we might have a little time, let's say. I mean, we're going to move on to the next chapter. I got to figure out what I'm doing next week. I might do like some video lectures, just like put them online. You guys watch it. You can do it at like double speed. Watch me go.
Instead of coming to class?
Well, I'm not going to be. I'm at a conference next week. I'll be back Friday, so I'll be teaching Friday.
I usually come in on Friday or something. I work at the bars on Thursday. Yeah, I'm getting up like 2:30, and I'm like, fuck, I want to get up. It's like get up and get on Zoom.
Silly Christian.
Yeah, nobody wants to come in on Friday.
I'm
So
very
you guys are
surprised
great.
we went on the
You guys are
Friday.
great. You guys are fantastic. I mean, donuts are coming for sure.
Yes! Only this, not actual class.
You have to bring it for me, Emma. And
Oh, there'll be prizes. I mean, I'll get some actually got t-shirts for students one time.
Oh my God,
I want a t-shirt.
You could get Curve's favorite student and put it on the back.
Yes.
And I will wear it everywhere.
I'll wear
I
it.
was talking to my kids about, so I do some programming on the side. And I was building this app. And it's like, think of the name of my company. And so I thought of Kerr App Inventions.
Huh.
What do you guys think?
I mean,
I like it.
We were going to do like a trading platform, like one example of an app. The Kerr App E-Trade.
There you go.
What do you think?
I think good.
Got all sorts of things. I want to put a Kerr app in every home. So yeah, I could do some t-shirts like advertising my new company.
Yeah.
I'll wear it.
If it's like an extra large, just get really big baggy t-shirts and I'll wear them.
The same people that own Varsity Donuts own Threads.
Yeah.
So they've been doing.
That's why they have like that whole wall.
Oh, yeah. That's all that means. All right, guys, go on.
A dishonest coin. Oh.
A dishonest coin. So, guys,
What is up with these coins?
it's really, look, you got the raffle example was a good example. So these are like the same thing. Yeah. The point is that you can always, there's so many models where it's like you have 2 options. You know, have you ever like binary trees where you kind of have these kinds of models? At each stage you have choices. So each of these times when you have like a probability that's assigning one or the other, you can think of these as a coin flip. And so a lot of, that's why these coin flip examples are always, they're sort of the simplest probabilistic model that you can repeat over and over again. It's actually a good, you'll see. I mean, so another thing that you can do, which is actually quite interesting, and I didn't get through the class, is you can talk about random walks, where you decide to move to the right or to the left based on a coin flip. You can like make it so that like you'll have a certain probability of moving one step to the right versus the left, like an uneven coin. If you do this over like large samples, you can kind of relate the velocity of movement to the probability. This is kind of like, you hate velocity.
It gives you PTSD to physics.
Oh, come on, guys. This is
Had a
beautiful.
very tough time.
That's actually very related to Brownian motion physics. So
I took physics and pre-calc senior year, and
All right, sorry, we're not doing your problems. Let's see. Okay, 62.
Fuck you. I do your problem.
He's just sitting there struggling.
I did say you could swear, so I know you can start with F. Okay, so probability is 0.75, so 3/4 plus 1,200 times. So here they do lowercase n. I never know whether they're going to, I mean, lowercase n is more standard. I use capital N because I thought that's what they used. Okay, so then at capital X, number of heads as a random variable. Okay, so find the mean and standard. That's direct from the central limit theorem. The mean is going to be, so it's not an average. That's the thing. So you can do this as the average, or you can do just the actual number of heads. So they're doing the actual number. So we want to do n times probability, the mean, which is going to equal 0.75 times 1,200, which is 900. Is right.
So would there be any like label on it?
Well, this is a number, so I guess heads. I guess maybe you're right. It's just heads. Units is the number of heads.
Yeah.
So now this has a general formula that we talked about very briefly at the end today, which is n times p times 1 minus p. You can find it in the book, but it's also comes from the central limit theorem. So that's 900 times 1/4, which is 9 times 360 square rooted, which is 6 times the square root of 10. I don't know. Oh, wait a minute. Sorry, I screwed up. Did I screw it up?
That's right. Square roots.
So I 900 times 1/4. I thought it was, sorry, 900 times 1/4. Just, that's 25. I screwed that up, sorry. 925 is 175. 170.
Scientific.
No, 225.
Yeah.
225. Sorry, I'm really slow. So 225. Oh, well, right, and that's 9 times 20 is 3 times, so 15. There you go. Okay, that's A. Find the first and third quartiles. So now this is the same thing that we've done several times. So the third quartile is going to be 900 plus 675. It's 27. Sometimes 3/8.
901.
The what?
910.25.
That's right. Should be 8s and 125. So that's right. And then again, you can kind of figure this out if you want. Take 2 times 9, 1800. So it should be 1, just by symmetry, it should be 89.87.
Minus.
Okay. C says something. Find the probability that the number of heads will fall somewhere between 900 and 945. Okay. Okay, well, you guys tell me how to do that. I can. Okay, I can do that. I mean, I can
Just like,
draw the approximate
Yeah.
graph.
I just have to be.
So we have this kind of mean here of 900. Standard deviation. It's like 15 here. So they're asking, what can you tell me about 945 and 900, these two numbers? This is in the context of this problem.
Just kidding.
You know, I like the way you're thinking, but what about it? What is 2z? What is, it's not really two z values. The z value is the number of standard deviations, right? So how many standard deviations to get to here? Well, what is this? 350. The standard deviation is 15 here. So if we move 15 here, then one more 15, and then another 15, then we'll get to 945. Okay, right. So good. So you're remembering that. So I've got 3 standard deviations. That's 945. And we know that, okay, so now if we look, the probability of landing in here is this area. So what is that area? Is it? Close. You're close, but you're right.
Oh.
All right, because you have, when we look at that rule, when you look at that rule, you're looking between the negative z value and the positive. So it's within 3 standard deviations of the mean. But here we're just going to the right of the mean. So that's half of that thing. Right. And so that's going to be 49 point something. What? 99.7 divided by 2.
Oh, 49. Sorry.
All right.
Calculators don't always know, I guess.
49.85, right?
Maybe it's user.
It's approximately this. So yeah, 49. So almost 50%. I think you guys can do it. I think this stuff is very doable. Believe me.
I just think that now makes
Well, give it a try, and if you get stuck, yes.
It's always a lot easier when like looking at the problem, just like whatever it's like this. I always feel brain dead when I'm just like talking about it when I see it.
I just can't do math.
Sometimes he's got his middle school math at that time. I don't know what to say.
I get up 30 minutes before I have to leave. That's an hour.
Damn chairs.